Hi everybody, in this video we are going to be talking about unit 13.1.2, which is graphing linear equations. Be careful here, sometimes we do this topic out of the regular order that it's in EdReady, so just be careful that when you're doing your homework you're checking for graphing linear equations in the topic so that you're not doing practice problems for a different topic instead. First, what we're going to talk about are just linear relationships. Like, what is a linear relationship? So a linear relationship is essentially a one-to-one relationship. It typically graphs a straight line, which is what we're going to fill in this first blank. It can be represented in a table. It can be represented in a graph and or an equation. So let's talk about the just typical equations that you would see for a linear relationship. Our standard form would look like this, where it's ax plus by equals c. And so we might have something that's like, maybe it's negative 3x plus 4y equals 10. And it could look something like that. It could be in slope-intercept form. And this is the form that we use most commonly with this slope-intercept form. And it's going to be y equals mx plus b, where m, again, is our slope of our line, and b is our y-intercept of our line. So again, our slope is going to be our rate of change for that line, and then our y-intercept is where the graph of our line crosses the y-axis. And so this would be our y-intercept. And then the slope tells us our rate of change. So maybe it's going up to right 3, up to right 3. And so that, again, is giving us our rate of change. All right, two other ways that we might be able to see our lines is that, sometimes we've got a horizontal line. So sometimes we've got our grid here, and then we've got a horizontal line, and it comes across, and the graph of that line, it's going to be expressed by y equals some constant, and it's going to be y equals c. So maybe the one that I just drew in there, maybe that's like y equals -4. And so if I have an equation of y equals -4, I need to be able to recognize that that graphs a horizontal line at -4. And so no matter where I would put my pencil on that horizontal line, my y values 100% of the time are -4, which is why it's y equals some constant. Like, what is the constant? That is constant. That is the same along that line. And for this one that I graphed down here, it's y equals -4. So the kind of converse of that is, well, what's our equation for a vertical line, a line that runs vertically? Instead of it being y equals c, it's going to be x equals some constant. And so maybe, I've got my grid in here, but then my vertical line, maybe it's over here and it looks like that. And maybe that's, I don't know, maybe that's like an 8 or something. And so the graph of my line here would be x equals 8, because no matter where I put my pencil on that line, what is the value that remains the same? And it's x. X is going to equal 8. And so those are our equations as we get ready to kind of talk about how we're going to graph these equations. All right, so our first technique that we're going to use to show you how to graph these is we're going to be graphing by creating a table. So first, we are going to make a 4-column table. Oh, I was going to sneeze. 4-column table. And we are going to choose a value for x. Then our second step is we are going to substitute it into your equation to see what the y value is. Our third step is going to be plot the ordered pair. Plot the ordered pair that you just found. And we're going to repeat this step until we have at least 3 ordered pairs. to graph. And then finally, we are going to draw a line through the points you plotted using a straight edge. So you can grab out your student ID, you can use the side of your book, the side of your notebook. Oh, sometimes the side of your phone, your case is a nice straight edge. So grab out a straight edge and you can graph your line through your 3 points that you found using a table. And we're going to talk about the 3 methods here. And then on the next couple of pages, we're going to do method 1 here, method 2 here, and method 3 over here. And so we're going to practice doing all 3 methods for each equation for the next several examples on that. So we're going to go through the steps here, and then you're going to keep this page handy. So you've got your steps right here in front of you, and then we're going to do, you know, method 1, 2, and 3 for each of those examples that are coming up. All right, so here's our next method. Our next method is that we are going to graph by putting an equation into slope-intercept form. Slope-intercept form, again, is in the form of y equals mx plus b. Well, why is that helpful? It's because it gives us 2 really great pieces of information. This again is our slope, and this again is our y-intercept. And so when we get ready to graph, we're going to graph our y-intercept, and then we're going to use our slope to graph additional points. So first, if it's not already done, we're going to solve the equation for y, meaning we're going to get y on one side of the equation all by itself. Then we are going to identify the y-intercept from the equation, and we are going to plot the point 0b. Then we are going to use the slope to graph additional points from the y-intercept. And finally, we are going to draw a line through the points that you plotted. And then our last method is that we are going to graph by our x and y intercepts. So our x-intercept is the point x comma 0, where the line intersects the x-axis. So again, it's our point. So let's say our graph kind of went like, oops, I did not mean to do that. To make it a little bit off. So our x-intercept is going to be right here where it crosses the x-axis. So we know that that point is some positive x, but what's the y? The y is 100% always going to be 0. No matter where I put my point somewhere on that x-axis, it's always going to be, my y value is going to be 0 because there is no vertical change above or below that x-axis, right? So that's true of my y-intercept as well, except instead of it being x comma 0, it's going to be 0 comma y, because 100% of the time my x values are going to be 0 for any point that's crossing on this y-axis. So let's finish up talking about the x-intercept though. So x-intercept, go back. We're going to talk about the point x comma 0 where the line intersects the x-axis, which was right here. To find this point from the equation, we are going to substitute 0 in for y and solve for x. Then we're going to plot that point. So we're going to substitute 0 in for y, and we are going to solve for x. For our y-intercept, we've got the point 0 comma y where the line intersects the y-axis. And to find this point from the equation, we are going to substitute 0 in for x, just like it says here, 0 in for x. And what are we going to solve for? We're going to solve for y. Then we're going to plot that point. And finally, we are going to draw a line through the 2 intercepts. So this is the one scenario where we're only going to come up with 2 points. The other ones we're coming up with 3 points. We should have 3 points for this one that we're going to graph, and we're also going to have 3 points for method 1 as well. All right. So let's look at these examples. And so method 1, again, is going to be us using the table. Method 2 is the equation, and 3 are the intercepts. one thing I think that is kind of hard when you're doing this is kind of like forgetting that excuse me, some of the information from the first method. So for example, let's say in method 1, we figure out what the X or the Y intercept is. We have to forget that we know that information as we move on to step 2, like our method 2. And then we forget the information that we found for method 1 and 2 as we look at method 3. So we can't just be like, oh, I already know what those pieces are, and I'm just going to write it down and not show the work. So you still have to go through the steps, because I may not ask you for all 3 methods on a quiz or a test. So that's why you have to know each of the individual methods here. All right, so let's make our table first. And for our table, we are going to make a 4-column table, and we are going to do X, and then we're going to do our equation, and we are going to have 1.5X. And then we have our Y, and then we have our ordered pair. Our ordered pair. All right, so I personally like to kind of spread my data out. So I look at what X values I have on my graph to work with, and what, how negative do they go, how positive do they go, how much vertical and horizontal space do I have, so I can spread my values out. I am also thinking about how 1.5, if I was to write that into a fraction, it would be 3/2 X. And so I'm thinking about what kind of makes sense, like what ordered pairs make sense for me to pick over here for my X values to cause this 2 to cancel out. So you could pick anything. You pick anything that's like a multiple of 2. So you could do 2, 4, -2, -4, -6. 0 is a good one. So you could pick anything like that. I've also had students say, well, can't I just pick 1? If I pick 1 in there, I'm going to get 1 times 3/2 is 3/2. So my ordered pair would be 1, 3/2. Yes, that's fine too. So the ordered pairs I choose don't necessarily have to be the ones that you choose. So here we go. I'm going to try to spread some of my data out. And I'm going to first choose -4. So then I'm going to have 3/2 times -4 over 1. And then I'm going to cross off. I've got 2 and a 4. So then essentially what I've got is 3 times a -2, which is going to give me a -6. So then my ordered pair that I'm graphing is -4, -6. So let's get that, and let's make sure it hits on our graph, and it does. -4, -6 is going to be right there. So the next one I'm going to try is 0. So that's pretty easy. 0. So I'm going to do 3/2 times 0, and that's going to give me 0, which means that my next ordered pair is going to be here at 0, 0. And then I'm just going to pick like a +2. So I'm going to pick +2. So I've got 3/2 times 2 over 1. It's going to be 6 over 2, or you could cross off the 2's here, which is going to give us 3. So my last ordered pair I'm going to graph is going to be 2, 3. So right 2, up 3. Now take your straight edge. Here I'm going to eyeball it for me, and I'm probably going to be a little squiggly because of the iPad. But you guys get out your straight edge and graph your line. And then supposedly, if I did everything right, the lines that I'm graphing from graph 1, 2, or 3, they should all look identical. I may not have the same ordered pairs that I find from each of the methods, but the shape and the chain, like the look of the graph should be the same. All right, so here's our second method. So this one was table. The next one's equation for slope intercept. And so I'm just going to rewrite the equation. I'm going to have y equals 1.5x. And so I want you to identify your slope, which is 1.5. And again, that would be like 1.5, right? Which is 3/2. And I want to change it to 3/2 because I'm going to go up 3, right 2, up 3, right 2, up 3, right 2. And then what's my y-intercept? What's my b? There's nothing written there. So it's as if there's like a +0, right? So my y-intercept's always going to be 0, something. Well, the something fills in right here. And so my y-intercept is going to be 0, 0. And then you should look back to our other graph. Does that match what we have? Yes. So now let's use our slope. So we're using our slope of 3/2. And we're going to graph 2 more points. We're going to go up 1, 2, 3, right 1, 2. Up 1, 2, 3, right 2. And then let's graph. And again, look at that. I totally missed 2 of my points. So that's why you guys should use your straight edge. My first one I did pretty well. This one looks pretty horrid. All right. And then again, I'm looking between my left and my right graph. Do they look the same? Well, the left one looks way neater, but I can tell that I'm hitting the same points. So far, so good. All right. The last method is finding my x and y intercepts. So my x-intercept, I'm going to write down that general form of the x, 0, like it said here. And it says substitute 0 in for y and solve for x. So that's what I'm going to do. Substitute 0 in for y and solve for x. So I'm going to rewrite my equation. And I've got y equals 1.5x. And it says substitute 0 in for y and solve for x. So I've got 0 equals 1.5x. I'm solving for x. Divide both sides by 1.5. And 0 over 1.5 here, that's 0. 0 over 1.5 is 0. So 0 equals x. Okay, well, that's not so helpful. So because what I found is that that 0 is going to plug in there. And so the ordered pair I would graph is 0, 0. Well, now let's look at my y-intercept. It's going to be 0, y, which again means I substitute 0 in for x and I solve for y. Again, that's from right here. I'm going to substitute 0 in for x and solve for y. So I'm going to rewrite my equation again. I'm going to have y equals 1.5x. I'm substituting again 0 in for x and I'm solving for y. So y equals 1.5 times 0 and y equals 0. So that means what I found was this. And I'm plotting the point 0, 0. So far I have 2 points on top of each other and it's not very helpful, right? Because both of them graph 0, 0. And so we can't graph a line through just one point. And so what we're going to do is use our slope to graph one more point. And so we're going to write that in. So this is one of the scenarios when using our x and y intercepts to graph a line is not so great. So if they both happen to be the same point, that's not at all helpful to graph our lines because we have to use another method. We have to use our slope. So let's go up 1, 2, 3, right 2. And by the way, so I've had students say, wait a second, you said we couldn't use other information. I'm not. I'm using the fact that we know that my slope is 1.5. Or if you want to go up 1.5, right 1, up 1.5, right 1, you can do it that way too. Up 1.5, right 1. All right, graph your line. And does it look the same as the last two? Yeah, it's pretty close. All right. One moment. I'm going to pause and I'll be right back. All right, I'm back. Let's do our second example. So we're going to do the table method again first. So here's our table. So we've got x, And then we've got 3, we're going to put our equation in our second column. So it's going to be 3/4 x minus 5/2. And I'm thinking about the fact that 5/2 is 2.5 as well. So that might be something else you're kind of thinking about too, where you're like, okay, that's also 3/4 x minus 2 1/2. So I'm going to write them both in there because it kind of depends on what x values I choose based on how I want to think about this number back here, whether I want to think about it like an improper fraction, a decimal, or a mixed number, whatever might be easier for my mental math game. Okay. And then we're going to have y, and then I'm going to put OP for ordered pair in there. All right, on this one, if we're kind of picking or choosing strategic x's that are going to cause that 4 here to cancel out, you can choose any multiple of 4. So I'm going to do something like -4, 0, and +4. And we just want to make sure it's going to land on our grid once we plug it in. And if it's just barely off, like if we have to extend our grid just a tiny bit, that's okay. But if it's like we've got the point -9 and it's 7, then I'm not going to graph that. I'm going to choose a different point. All right, so here we go. This time I'm going to choose -4. And so we're going to have 3/4 times -4/1 minus 2 1/2. And so my 4's here are going to cancel. Don't forget the negative though. We've got a negative here. And so I've got -3 minus 2 1/2, which is going to give me -5 1/2. So I'm going to get -5 1/2. And so then I'm going to graph the point -4, -5 1/2. So -4, -5 1/2. So about right there. Now I'm going to plug in a 0. So I'm going to do a 0. So 3/4 times 0 minus 2 1/2. 3/4 times 0 is going to give me 0. Minus 2 1/2 is going to give me -2 1/2. So my ordered pair is going to be 0, -2 1/2. So put that there, 0, -2 1/2. And then I'm going to pick a +4. +4, so I've got 3/4 times 4/1 minus 2 1/2. So the 4's here are going to cancel. And then I've got 3 minus 2 1/2. So 3 minus 2 1/2 is going to give me a +0.5. And then I'm going to get 4 1/2. So 4 1/2. And now I want to look and just make sure, does that look like it's going to create a linear relationship or a line? And it does. And again, look at that. It's terrible. You guys use your straight edge. All right. So we've got that. Now let's look at our second method. Second method is our equation. And we would put it in the form of slope-intercept if it wasn't already in slope-intercept form. So far, we've been pretty lucky, and it's been in slope-intercept form for us. And so our slope, we're going to just identify what it is. It's 3/4. And our y-intercept is going to be 0, -2 1/2. So we're going to graph the point 0, -2 1/2 right here. And then we're going to use our slope of 3/4 to graph it. So we're going to go up 1, 2, 3, right, 1, 2, 3, 4. And it doesn't look like if I went up 3, right 4, it's going to land on my grid. So I'm going to come back down to my y-intercept and I'm going to go down 1, 2, 3, left, 1, 2, 3, 4. And do our point, and then draw your line. And I want to look between my line over here and my first method and see if they look the same, and they do. It looks great. So it looks like we're doing everything right. It's great that they're matching up. If they're not matching up, then you should go back and check, because that means you did something wrong in your process. So now we're going to do the final method of our x and y intercepts. So our x-intercept is going to be x, 0, which means, again, that it tells you what to do. It says substitute 0 in for y and solve for x. So we've got y equals 3/4 x minus, I'm just going to leave it as 5/2 this time. And then I'm substituting 0 in for y. So I'm going to have 0 equals 3/4 x minus 5/2. I'm going to add the 5/2 over. And then I've got 5/2 equals 3/4 x. And we want to get rid of that 3/4. You can divide both sides by 3/4, which is the same as multiplying by the reciprocal. So again, remember, if we're dividing by 3/4 like that, we change this to multiplication, and then we flip. So it would be like 3/4 times 4/3. And if we're going to multiply by 4/3 on one side, we need to multiply by 4/3 on the other. So we're going to multiply both sides by 4/3. So then this cancels out. And then we're going to end up, I'm going to go ahead and reduce the 2 here. So I'm going to end up with 10/3 equals x. And so take 10 and we're going to divide it by 3. And that's going to give me x equals 3 1/3. And then we're going to write that as an ordered pair, and we're going to graph that point. So we're going to have 3 1/3, 0. And we're going to go graph that point. So go 3 and then over just a tiny little bit. And we're graphing that. And then I would look back and say, is that about where this graph hit? It's pretty close. Is that about where this graph hit? That's pretty close. And then let's look for our y-intercept. So our y-intercept is going to be 0, y. And again, this tells us to substitute 0 in for x and solve for y. So we're going to write in y equals 3/4 x minus 5/2. I'm going to plug in the 0 for x. And I'm going to say y equals 3/4 times 0 minus 5/2. So the 3/4 times 0 is going to give us 0. So we're going to get y equals 0 minus 5/2. And 0 minus 5/2 is negative 5/2, or negative 2.5. So we're going to write that as an ordered pair. We had 0, negative 2 1/2. So one of my points is again here at 3 1/3, 0. My other one's at 0, negative 2 1/2. And I am plotting the line that goes through those 2 points. And then you'd look back and say, okay, does that match these other 2 lines? And yeah, it looks pretty good. So that tells us that we did that part right. So we've got 2 more examples to walk through that are similar, but also different in their own way. So our next one, we are going to take our table method again. So we've got our table, and it's going to be x, and then we've got our equation of y equals negative 3. I'm going to go ahead and write it as, I'm still going to do it as like mx plus b, because I need to put my x in there if I'm going to substitute values in. So I'm going to do 0x minus 3. And again, I'm doing 0x because I don't have any x, right? Like I just have the plus b on there, which is plus a negative 3. So then I'm going to do my y, and then I'm going to do my ordered pair. So this one is choose an x, any x, as long as it's going to land on your grid. And maybe we choose, I don't know, like negative 2. And so we can do 0 times negative 2 minus 3. Well, that's going to give me 0 minus 3, which is negative 3. And then I can graph the point negative 2, negative 3. So negative 2, negative 3. And then I'm going to choose x equals 0. Oh, I have no idea what just happened there. Okay. So I'm going to choose 0. So then I'm going to do, now my pen doesn't want to work. Now it looks like it's gonna work. Okay, sorry about that, guys. I don't know what happened there. Okay, so then we're gonna do 0 times my 0 that's here, minus 3. So 0 times 0 minus 3 is gonna give me -3. So then I'm gonna graph the point 0, -3. And then, I don't know, let's try 5. Right, positive value, so we're gonna have 0 times 5 minus 3. 0 times 5 is 0 minus 3, which is gonna be -3. And then I'm gonna graph the point 5, -3. So 5, -3. And then you can draw in your line through those points. So there's our table. Then for our equation, we've got y equals -3, but I'm going to go ahead and write it as y equals 0x minus 3. Our slope is going to be 0. Our y-intercept is going to be 0, -3. And so we're going to put the 0, -3 down here. And then we've got our slope of 0. So we're going to go, you know, up 0, however many over, like we could even express this if you wanted to as like something like 0/2. So we could actually say, okay, we're going to go up 0, but we're going to go right 2, up 0, right 2, up 0, right 2. And then graph your line. And then our last one, Kale. No, please stop. Our last one over here, we're going to do our x and y intercepts. So we're going to have our x-intercept of x comma 0. And we are going to substitute, again, this tells us to substitute 0 in for y and solve for x. So we've got y equals 0x minus 3. So let's substitute our 0 in for y and find out what happens. So we're going to get 0 equals 0x minus 3. All right, 0 times x is going to equal 0. And then if we do 0 minus 3, that's going to give us -3. Well, what happens there? What does that mean? Does 0 ever equal -3? No. So 0 does not equal -3. Well, what does that mean about an x-intercept? We don't have one. Look back. Did our line ever cross the x-axis here? No. So that's the conclusion we make. No x-intercept for that. So now let's figure out our y-intercept. So our y-intercept is going to be 0 comma y. And so again, we are substituting 0 in for x. We're solving for y. So we're taking this 0 and we're plugging it in right here. So we're going to have y equals 0 times 0 minus 3. And y is going to equal 0 minus 3. And y equals -3. So then our point is going to be 0, -3. So here is yet another example. I don't know if you guys remember from example 1 where it did not, this method was not so great, like graphing an x and y intercept. So I don't know if you remember from example 1, they both landed on the origin. Well, this time all we have is 1. There is no x-intercept. There's just a single point. So this method kind of stinks for this type of line as well. So now we use our slope of 0. Use slope to graph additional point. So my slope is 0, and I'm just going to put another one over here, and we're going to graph our line. All right, last example. And you guys should pause the video and see if you guys can do this one fully on your own and see how it goes. And then come back, check out the video, make sure you did okay. All right, so table method. Excuse me, we've got x. I'm going to put in my equation of -2x plus 1, and then I've got my y, and then I've got my ordered pair. So we've got, it doesn't really, like as far as strategic x's, we don't really have like a denominator to cancel out, but I do want to be careful about what x I choose so that it will still land on my graph. So the largest one I might want to choose, you might want to think about like a 3 or a 4 and say, okay, if I plugged in a 4, I'm going to get -8 plus 1, which is -7, which doesn't land on my graph. So maybe something like a -3, a 0, and a 3. You try something like that. So let's do that. I'm going to try that. We're going to do -3 first, and then let's see what happens. So we get a -2 times a -3 plus a 1, and this one's going to land just off because we're going to get a +6 plus 1, which is 7. If you want, you can continue on with that. I'm going to choose to go back and say, I don't know about that. And I wanted to show you that that can happen. So typically on this one, I will choose like a -2, but I wanted to show you why. Because if it lands off your grid, you can go back and choose something else. All right, so we're going to do a -2. So we've got -2 times a -2 plus 1. -2 times a -2 is 4 plus 1, which is going to give us 5. And then we can graph the point -2, 5. So -2, 5. And then I'm going to choose a 0. So then I've got -2 times 0 plus 1. -2 times 0 is 0 plus 1. And that gives me 1. And then I'm going to graph the point 0, 1. And then I'm going to try a +2. So then I'm going to do a -2 times a +2 plus 1. So that's going to give me a -4 plus 1, which is going to give me a -3. So then I'm going to get the point to -3 to graph. So to -3. And then grab your straight edge and then draw your line. All right, so now let's use our equation. This one's actually already in slope intercept form. So our equation is going to be m equals -2. Our y-intercept is going to be 0, 1, so right here. So now let's go graph our y-intercept, 0, 1, and it's going to be up to left 1, up to left 1, or you can go the other way. You can go from here down to right 1, down to right 1, get at least 3 ordered pairs, and then graph your line. Again, check compared to the other one. Does it look right? Yes. And now let's do our intercepts. So our x-intercept is in the general form of x, 0. And then this one is telling us that we're substituting 0 in for y. And we are substituting, or we're solving for x. So we're going to have y equals -2x plus 1. So this says take the 0, plug it in for y. And we've got 0 equals -2x plus 1. I'm going to subtract the 1. And I get -1 equals -2x. I'm going to divide both sides by the -2. And I get x equals +1/2 because we've got the negative over the negative. So I'm going to write that as an ordered pair. So that 1/2 means I'm substituting it in for the x I just found. It's going to be 1/2, 0. So I'm going to get it right here and then look back. Does that look about where the other ones are hitting? Yeah, it looks good. All right, now let's do my y-intercept. So my y-intercept is going to be 0, y. And so again, this says substitute 0 in for x. So I'm going to have y equals -2x plus 1. And I'm going to say y equals -2 times 0 plus 1. And this is going to give me 0, the -2 times 0. So it's going to be y equals 0 plus 1. Y equals 1. So then I'm going to write that as an ordered pair. So it's going to be 0, 1. Here is where it's super important to use your straight edge, because I don't want to just draw a little line segment like that. You need to extend it through those 2 points. So extend it through your 2 points. And then look back and say, does that look the same? Yeah, it looks pretty good. All right, so I know we've got more pages in this for this topic, but this is part 1 of this video, and then I'm going to stop it, and then I will get ready to record part 2 for you to finish up this topic. Thanks for tuning in.